if you look on the outside, it looks like a spider. Right? So that is called a myoepithelial basket cell. So basket, because it sort of looks like a wicker basket surrounding the alveolus. It is a smooth muscle cell. Myoepithelial basket cell, a particular kind of smooth muscle. And so, if we look at the one on the left there, you can see the myoepithelial basket cell on the outside, our secretory epithelium. We have a big space or lumen on the inside of that alveolus. That's where the milk is going to collect as it is produced by the secretory epithelium. And then this one is just, showing you the branching pattern and ending in the alveoli. All right, now what's going on here? So the major stimulus to get the milk out of the lumen of every one of those thousands of alveoli, right? So its terminal branching pattern ends in the alveoli. That's where the milk is. And you've got to get it out of there and into the kid's mouth. How do you go about doing it? Well, there is a certain amount of suction that is being made by that youngster because he's able to use his facial muscles that reptiles lack in order to latch onto that nipple and create some suction. But in reality, to get the majority of that milk from the depths of the alveoli up to the nipple so that the youngster can then use its suction to remove it, in order to do that requires a different technique. And it's an example of a neuroendocrine reflex. Do we have any of those in this class yet? I had a few in mammology, that's why I asked. This is a reflex, so it's not something you think about, but it's going to involve nervous communication, so electrical signals, as well as chemical signals, a hormone, part of the endocrine system. Right? The two of those then will be involved in this particular reflex. Right, so what goes on? All right. The nipple of the female is stimulated. We have physical stimulation of the nipple. That then is going to result in electrical impulses to the brain. So nervous input. Electrical signals going from the nipple to the brain are being stimulated. Specifically, it goes to the hypothalamus. Major area of the brain, lower part of the brain. And the hypothalamus communicates with posterior pituitary. If you ever look at a brain, there's the underside of your brain. Right. Wow. That's hypo. That would be your hypothalamus, and hanging down like a grape on a stem below the hypothalamus is the pituitary gland. So they're very close to each other. We got our nervous part of our reflex. Now we need the endocrine part. Hypothalamus tells the posterior pituitary to release a hormone into the bloodstream. That hormone is oxytocin. That hormone now travels through the circulatory system to the mammary gland. When it reaches the mammary gland, the effect of that oxytocin is that it causes contraction of the myoepithelial basket cells. So you have thousands of these alveoli, all containing a little bit of milk. You have these basket cells on the outside. You can just think of them almost like a hand. And the effect of the oxytocin is telling that hand to contract. Squeeze down on that alveolus. And thousands of myoepithelial basket cells all doing this at once push that milk up and out from the depths of the mammary gland. A youngster, doesn't matter what species, does not have enough ability to form suction to drag that milk out from the depths alone. Instead, it has to be aided by this milk ejection reflex. And I do remember in taking an endocrinology course when I was a PhD student and being forced to watch a movie. You think my tests are bad? It just occurred to me. I took the exam after the movie, and one of the questions was, what was the name of the bald-headed gentleman in the milk ejection reflex movie? I could tell him everything he wanted to know about the milk ejection reflex. Anyway, but in that movie, they took a lactating rabbit, and she was anesthetized, and they tied her down, and then they just injected oxytocin into her system, and it was immediate. Was just the milk shot out of every one of her nipples. The milk ejection reflex, an example of a neuroendocrine reflex. Human females are no different, right? And you can see it even in human females. A human female who has an orgasm can release oxytocin into the system. So if you have a human female who is lactating and she has an orgasm, it can cause the release of milk from the nipples. Okay, so it's a cool thing because it's totally mammalian, the mammary gland and how it works. It's also cool because it illustrates a neuroendocrine reflex, which is really a common thing that occurs in animals. Questions? All right. And I have to finish with teeth. We're off epidermal derivatives. Just a lot of terminology here to make some comparisons among reptiles and mammals. Okay, so if we look at the reptiles, reptilian teeth are homodont versus a mammal being heterodont. I think most of you understand that conceptually already. If you look at the teeth of our modern reptiles, from the front to the back, they have essentially the same shape. That's what the homo means, same. Dont meaning tooth. They may be different in size, but the shape, and therefore what that tooth can accomplish, does not vary from the front to the back. Whereas in most mammals, we do see differences, distinct differences in shape. And so you can think about the incisors in the front, think about the canines, and then think about the premolars and molars, what we call the cheek teeth. They have very, very different structures. And because of that, they can have very different functions. We'll get into that. how are the teeth attached to the jaw? Most reptiles are acrodont or pleurodont. Whereas all mammals are thecodont. Yeah, no, you don't necessarily remember what those mean. If we look at acrodont, this is a cross-section of the jaw, let's say the mandible of a reptile. In acrodont dentition, that tooth is just loosely attached to the top of the bone. Acrophobia, fear of heights, acrodont. The tooth is on the height of the jaw. Pleurodont this would be out, this would be in. Most of the tooth sits on a little ledge on the side of the tooth. Pleural always is referring off to the side. But in mammals, we have our teeth in a socket, encased by bone, surrounded by bone, very, very firmly attached to the jaw, as opposed to these guys that have it just sitting on the top or sitting on that little ledge. Reptiles can get away with that because they have polyphyodont dentition. Whoops, missed the Y. Physis means growth, dont means tooth, poly means many, many growths of tooth. These teeth are not well anchored in reptiles. They fall out all the time. They replace them all the time. Right? So they're going to have many different growths of teeth throughout their life. Mammals, by and large, are diphyodont. They have only 2 sets of teeth in their lifetime, di, physis, dont. You know about the milk teeth, lacteal teeth, the deciduous teeth. That's what a youngster has. And then they're replaced by the adult teeth, which last potentially for 80 years. They can last for 80 years because they're locked into a socket. They're not as likely to fall out as in your acrodont or pleurodont. All right, so we have differences in shape, differences in attachment, differences in how often the teeth get replaced. All of these relate to differences in function of the teeth. So think of, you're looking at a jaw like that. And that could be a typical reptilian jaw. You have these teeth coming down. They all have points on them. Imagine that you're looking at the plane of occlusion where the jaws are coming together. So we have that. Let's turn it and picture it. Something like that. Teeth like this are great for puncturing. You know, you can put holes into your prey. You can hold on to your prey pretty easily with those kinds of teeth.